Welcome to Spring LIB.
Hi there. Today we're talking about a problem with a guitar string. We're told in the problem that the guitar string is vibrating at 440 hertz with an amplitude of 3 millimeters and no phase. So when we're looking at the idealized equation for simple harmonic motion, I've written it in green on the right. So the first part of this problem, part A, asks us to write down, instead of this generalized form of the equation, a real form of it. So we're basically just going to plug in all those values that we already have. So we have x of t is going to be equal to the amplitude, which we know is 3 millimeters, times the cosine of omega t. So we have the frequency, but we don't have the angular frequency omega. But it's simple to get from one to the other. The angular frequency is just equal to 2 pi times the frequency. So if we put that in down here, that's 3 times cosine times 880 pi times t. And then there's no phase. So that's the whole equation. It's possible to, it's really important to make sure that you know that this 3 is in millimeters and that this part over here is in radians. The argument of the cosine is in radians. So let's go ahead and look at part B. Part B is asking for the velocity, acceleration equations, and their maximum. So we know to get from position to velocity, you just take a derivative. So v of t is going to be equal to 3 times 880 pi. There's also going to be a little negative sign out there, times the sine of 880 pi t. So that's what we're looking at. To take the maximum of this, we just remember that sine only oscillates between 1 and -1. So we can call it -1 to cancel out this 1 at the beginning. And we can say that the V max is going to be equal to 3 times 880 times pi, which is going to be approximately 8,293. And if you're saying that sounds like a big number, we got to remember that this is millimeters, not meters. So that's 8,293 millimeters per second. The next part, we're looking at acceleration. So we just take another derivative. We've got a of t is going to be equal to -3 times 880 pi squared times the cosine of 880 pi times t. This one, again, we're going to take the maximum, and it's going to be very similar. We're just going to say that cosine is going to go to -1 because that's going to be where this function maxes out. And we're going to take -3 times 880 times pi times 880 times pi. And we get the acceleration max is equal to 2.29 times 10 to the 7. Some of you might be looking at that again and saying that's really high, but we always got to remember that this is just millimeters per second squared and not meters per second squared. Finally, on this problem, we're looking at a quantity called the jerk. The jerk is the derivative of acceleration. And as far as simple harmonic motion goes, you just kind of keep taking derivatives. So we get j of t, the jerk of t, is going to be equal to positive now because we're switching from cosine to sine. 3 times 880 pi, now we're all the way up to cubed, times the sine of 880 pi times t. I think the second part of this question asks where the jerk is maximized, and this is another one that's really pretty easy to do. You just put the values in that you're looking for. We're saying sine is going to go to 1, so 3 times 880 pi cubed, and that's going to give us jerk maximum is equal to 6.34 times 10 to the 10th. Units are important. This is going to be millimeters per second cubed. That's how you do this guitar problem. I hope this helped.